No, I messed up. Yeah. No, this is correct. I'm sorry. I'm a little out to date. Too much travel. When you don't know which city you are in, you know you're in trouble. Okay, so x momentum flux minus x momentum flux. And I pause for a moment. I just want to make sure I get the sign right. Okay? So this is a verbal description in layman terms, just like you did with the hydrodynamic. Forces change the momentum. Now in fluid, we say forces change the momentum flux. And that's how we will use this formulation with more complexity once you get comfortable with it. Okay. So the other detail I want to revisit is how one deals with the pressure force. So that control volume I pulled out again. And for this trivial, simple problem, is, I hope, transparent. But later on the homework, it's going to get more dicey. So remind me, how will the pressure force act on this black box? And I'd like you to visualize, you take this black box and submerge it in water. You're going to ask yourself, on all the surfaces, what is the relation between the pressure and the surface? Which direction? Which direction? Inward. And normal. Very good. Please remember that. There's no bearing on the velocity direction. Even though on the left side, velocity coming in, on the top and bottom, velocity is going out, I don't care. Pressure is pressure. Okay, question. All right, this is all repeat, but they are very important reason why I repeat them. The next one is a pretty spicy question for you. So in this diagram, from engineering intuition, we know the force anchoring the plate that I have to add has to be pointing to the left, right? Anyone who do not agree with that? Is that something intuitive? Okay, good. So suppose at UVA, where they don't have any engineering intuition, the professor come in and say, well, I don't know what the force will act. And I'm going to assume it's actually pointing to the right. And I'll call that F opposite. Okay, you're laughing now, but some homework forthcoming, you really have no idea which direction the force will act. Because the point is so compact, you look at it, you cannot tell. And this is why this is so important. Will I get the same answer? Which is this one. Will F, as done previously, equal to F opposite? With a negative sign. Very good. Very good. What does that negative sign mean in the context of this new force that I draw?
You assume in the wrong direction.
I assume in the wrong direction, you dummy. Right? It's no longer pointing to the right, which is positive x. When you use the same equation in here, and you do the sign very, very carefully, you will find out, at the end of the day, when the dust settles, F opposite is exactly in magnitude as this guy, except it's a minus sign. Minus meaning, in reference to the coordinate plus x, this is exactly opposite. Do you trust me? You shouldn't. So you should do this at home. I want you to do this at home, reverse the direction of the force, and work through it. It only takes you 3 minutes, and you will find the answer doesn't change. Okay? Clear enough? All right, last piece of detail. And this is relevant to the next homework problem. In the reading of the text, there's a lot of references to force acting on control volume and force acting on the plate, etc., etc. So I want to take a moment to explain that without confusing. First, by this summation Fx, in the momentum equation, we are referring to the forces acting on the control volume, and that's clearly in the example that we did self-explanatory. So here's my control volume, and when we say summation Fx is all the forces acting on the control volume. Now I'm going to break it up using free body diagram. So in that context of the momentum equation, we have a force F that we asked to calculate, and that's the force to hold the plate that act on my control volume as shown. Now the free body diagram on the plate itself, if I just forget the jet, just take it out, don't look at the jet, and what I have is actually following. I still have the anchoring force F, the unknown I'm trying to solve for. There's an equal and opposite force of F prime. So that is in equilibrium. So this F prime is the equal and opposite force than F, but it's exerted on the plate due to the fluid in such a way that they are equal and opposite. Do you follow? I know this is kind of a little bit trivial. It's almost, why am I wasting time? But in your reading, in the next example, this will have some bearing. Yes?
So you list the sum of forces in X, the sum of F of X is the forces acting on the control volume.
This is all forces acting on the control volume. Yes.
So you would consider the jet to be acting, the force of the water jet to be acting on the control volume as well.
Say that again.
So you, like, the force of water from the jet would be acting on the control volume as well.
No, the forces from the jet is acting through this plate, but is now represented on the control volume by this force F. Remember, I draw the control volume including the plate. All this interface interaction is internal, and I don't see it. Maybe you will wait until I finish all my categorization. Hopefully that will make it a little bit more transparent. It's very dangerous for me to go through this, because I may end up confusing some of you. And I can see that happening. Okay? So the last piece I want to finish is now looking at just a sheet of water, not including the plate. All right? For the water alone, not including the plate, if I draw the water as my control volume, I will have a reaction force R. And it's in such a way that the relationship between this different boundary of the plate as my edge of the control volume, which is how we start the problem. And now I deliberately choose the edge of my control volume, not including the plate, where I'm looking at the boundary of the water edge. It resulted in this relationship where all been told the least confusing way to approach the problem is simply the way I started, of which I draw my control volume not at the water interface, but including the plate. And the reason this detail is brought up is because in your reading, you may find that to be very confusing. In terms of problem solving, the approach I started will be the most advantageous and least confusing way to deal with the problem. All right. Having said that, I think the next example, which is your homework, may help clarify some of this. All right. So let me set up that problem, and then we leave this for you to have a chance to ask questions as you see fit. So bear with me so I can use the homework to help further explain this concept. So problem 536 is where I have a rectangular block. There's a weight and a dimension given. And in the problem statement, you'll find that the width